Hey guys, welcome to this first incredible installment of Chemistry Learning Amazingness. What's probably happened is you took a quiz and you realize you have no idea how to do significant figures, even though I taught you how to do it. And so here is the video explaining how to do it again to refresh your memory and get you all those amazing A's that you want so badly. Okay, so let's look at significant figures. And why is this important? Well, it's important because when we're doing science, we have to pay attention to this because we're making measurements and we're using numbers, and their significance indicates how precise they are. Anyways, that's the reason behind it. So first of all, when you're doing significant figures, you need to know what side to start on. Okay, so this is a little, well, it's a very nicely drawn map of the USA by myself. And so if you think about this map of the USA, you can think about the Pacific Ocean on this side, the Atlantic Ocean on that side. And that'll help you know where to start. Because Pacific, is the same letter that period starts with. And so if you see a period in the number, which is really a decimal, but, Pacific starts with a P, and so... Anyways, so there's period right here. If you see a period in that number, you're going to start on this side. You're going to start on the Pacific Ocean side and go across the U.S. If you don't see a period in the number, you're going to start on the Atlantic side because it's absent. The absent period, you're going to go that way. Okay, so that gives you a reference on which way to go. All right, so here's the rule, and you got to memorize this rule. You got to understand this rule. This is huge. Once you know which side to start on, you're going to start counting at the first non-zero and then count all the rest, including zeros. That's the rule. That's the only rule you got to remember, other than what side to start on. So I see a period, which means that I need to start on the left-hand side. So I need to start on this side, the Pacific Ocean side, because I see the period. Now I'm going to follow my rule. My rule says to start counting at the first non-zero. There it is. It's right there. And then I'm going to count all the rest. Turns out I only have 2. So this particular number here has 2 sig figs. Let's check out this one. See a period as well. So I'm going to start on this side. And I'm going to see the first non-zero is the very first number. I'm going to count them all. This also has 2 sig figs. This one has no period, and so it's absent. So because it's absent, I'm going to start on this side, the Atlantic side. Boom, I just get these 2. This also has 2 sig figs. Now I'm going to come over here. This has no period. It's absent, so I'm going to start on this side. And once again, I'm going to start counting at the first non-zero, which is the first one here. 1, 2, 3, 4, 5, 6. See, you count all these even though they're zeros, because all you got to do is just think, I'm going to start counting at the first non-zero and count everything. So this guy right here has 6 sig figs. Looking over here, I see a period, so I'm going to start on this side, Pacific Ocean side, start counting at the first non-zero and count them all. 1, 2, 3, 4, 5. And yes, you count that 0 because once you start counting, you count everything. All right, once again, here's another period. And so I'm going to start on this side. I'm going to start counting at the first non-zero, which is this one. I'm going to count all the rest. So this guy has 3. All right, that's how you do it. That's the only way to do it. All right, now when scientific notation pops up, it looks a little different. And how do we do it that way? Well, they always have a period, so you could just follow the same rule. But the thing is, what do I do about this part? Well, this part is just for the insignificant numbers, so you're not going to worry about that part, the times 10 to the whatever. You don't need to worry about that. All you got to do, literally, is count every single digit, because in scientific notation, every single digit that comes before the times 10 to the is significant. So that has 3. And then this also has 3. So scientific notation is easy. Don't worry about the times 10 to the thing. And then all of these are significant. All right. So now here's where you actually use the sig figs. Okay. So now when you're doing chemistry and you're doing physics, the rounding is really, really, really important. And so we're going to round for multiplication one way and then addition, subtraction another way. Multiplication, division. What you're going to do is whatever numbers you used to calculate, whatever measured numbers you used to calculate, you're going to look at those numbers, and whichever has the least number of sig figs, that's what you round your answer to match, okay? So this tells you what to round to. Now, when you're doing just straight addition, subtraction, there's no multiplication or division in it, then you are going to match your number to the least number of decimal places, okay? So sig figs is for multiplication, division, and addition, subtraction is decimal places. And once again, it's always least, because whatever has the least number of sig figs and the least number of decimal places is the least precise measurement, and therefore that limits all the rest of them. Okay, so let's take a look. Let's say that I had this set of data right here, 3.59, 4.3, 5.678, and I was multiplying that data. This is the number that I would get. So what do I round that to? Well, I'm going to look at the data that I use to multiply. I'm going to say, okay, that has 3, that has 2, and that has 4. This one right here with only 2 sig figs is the one that has the least amount of sig figs. So this one has 2, and so I'm going to round this answer to 2 sig figs, which means my 87 point blah, 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 blah is going to round to 88. Okay, so that number rounds up because of this number here to 88, and that's my answer. Now, once again, here we go. I got some division, so I'm dividing this by this by this, and so what do I round to? Here's my number right here. Well, this has 4, this has 3, and this has 2. So if we're doing our sig fig rules, we got periods here, so I'm counting, and I find out this has 2, which means that this number has to be rounded to 2 sig figs. Well, this right here, this 8 is the second sig fig, so if I round that from the number before it, that's going to stay in 8. And so this number becomes 28,000. And so the rest of this all becomes 0. So 28,129 point blah, 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 blah. This rounds down to 28,000. Now, putting this in scientific notation is also a good idea. 2.8 times 10 to the, so what you would do is you would go 1, 2, 3, 4. So times 10 to the 4th. That is also a good way to express this answer. Notice it just gets rid of all these extra zeros. And then your calculator would probably say 2.8 e to the 4th, which is also the way to express it. So all 3 of these answers are correct. You may, on a computer test, need to make sure to know how to put this in. All right, so let's go ahead and look at addition, subtraction. That's how I spelled that. I'm not sure. I think that says examters or examptus. So anyways, what we have here is we're adding these all up. Now remember, for straight addition, subtraction, no multiplication, division, you're using the least number of decimal places. So I look through, I got 3 decimal places, 3, 1, and 2. So that means that my least number of decimal places is 1. So this number needs to be rounded to 17.4. Okay, that's the final answer on this guy right here. And then finally, you're going to need to sometimes do dimensional analysis. Now, the nice thing about dimensional analysis is that that very first number, which is on here, tends to be the measured unit that is going to limit the rest of your answers. Now, you also may have taken some other measurements and therefore gotten some other significant digits, maybe lower than 3, so your answer might have to be lower than 3. But typically, this first number right here is going to be the one that determines your sig figs. These are conversion units. You never use those for sig figs. So if this has 3, I've got to round this to 3 sig figs, which means that this is my number I need to round right here. So I'm going to be 1.91, because I'm doing scientific notation. 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th. And then I'm also going to label that how I should. Atoms, always put in your labels there for your units. Okay, well that does it. That should help you to understand how to do sig figs. Thanks for watching.